let's try to figure out what we did, okay? And you guys have, many of you have thought about it. Those of you who got A's probably didn't bother to write the diary there. But think about it. This is useful for everybody. So we had many things going on in this course, and we can analyze the course from various points of view. The project you did, the topics we covered. We could have covered the topics without a project. We could have done lectures, pure lectures or pure videos. We had PRAXIS too, so that was a quirk in the course. There were diaries, there were quizzes, there were exams. Exams, of course, every course is required to have. So that's what we did, and hopefully we didn't do it just for the sake of doing things. There was, this was meant to help you in the future in some way, and there are many ways what you learn can help you. I once attended for a semester the Center of Teaching for Teaching Excellence, where they talk about what you're supposed to teach in the course and explain what the learning objectives are. And most instructors, this is instructors from all kinds of fields, say that we taught you how to think. Okay? And I think that's very important. That the most important thing you can learn from college is how to learn. So when I went to undergrad, that's what they told me, that forget about the specific things you're learning, you'll just learn how to learn. You can pick up anything afterwards. So that's very abstract, but let's get a little bit more concrete. What can be your future? Your future can be doing more courses in computer science. Some of you are deciding that, okay, whether you're going to major, because some of you are majoring in other fields and deciding whether this is going to be your second major or something else. Okay? You might get various kinds of jobs. Here we have an army of LAs. Okay? You saw some LAs here. In 110, if you've taken 1 and 10, the word army really holds true there. 401 that KMP teaches also has an army of LAs, okay, for a much bigger class. In fact, just as an aside, not only is this the last class 401 for you, this might be the last 401 I teach for a while, because we can't really afford 2 instructors. It's just the way we are shorthand teaching 401. And his course is amenable to a large number of students. So I might see you again in another advanced course. Okay? It'll be optional, you don't have to see me. There might be internships, and this is where I want to emphasize that be bold. You are qualified for just about any internship. Okay? And that has been my real goal. There's a lot of people taking computer science courses around the world, and the idea is how can I distinguish you guys from others? Okay? And that was one of my goals. There's a lot of research going on in the department, and 2 of you have already contacted me. If more of you want to do research, contact me or other faculty members. That's a great way to learn things. Even if you don't go, if you want to go to grad school, research really good. And getting into research early, you'll really do better. And research means many things. You can work with, it doesn't mean you're doing anything independent. So you can work with a grad student who's doing a PhD or a master's, or you can work directly with a faculty member. So there's many ways you can. Research is doing something new. And this is the world of mobile computing and Internet of Things, and you may want to just use your creative capability to build an app. Okay, so what you learn here help you in any way there, perhaps. So rather than going in, I've got some prepared slides, but let's just talk about given these goals here, specifically did anything here. Especially again, I want to, as engineers, we tend to be nerds. We tend to do things rather than talk about them. Okay, that's a classic stereotype, right? The liberal arts people can, talk well and maybe not deliver as well. Okay, so the one quality that I really want engineers to improve on is being able to articulate. So. Let's talk about, and I read some of your diaries this morning, and I in fact changed my slides a little bit and added a few things I haven't thought about. So, advanced courses. What do you think you did here that might help you in advanced courses? So my goal here was that there are some courses that are required, like 410, 411. I was not going to try and teach you unless I really needed them for the project that will prepare you for those courses. Okay, that you will take and just take it properly. But there are some courses that are optional. Okay? And, but they are important. All courses are important. And one of the laments of industry is that, oh, they're not prepared for the things we want them to do. Okay? So I wanted, important parts of sort of the optional courses to be done here, and thereby also make you more prepared for those courses, because those courses tend to be harder and taken by fewer students. So can you guys think of any optional courses that you know about, for which you got some extra preparation in this?
Operating systems.
Operating systems, and what subject did you learn that would help you in operating systems? Threads and concurrency. And, I made that, so that's a complex concept, okay? And concurrent programming, even if you know how it works, is hard to sort of master. So you never quite master it, but you got an introduction to it. And people have always thought that you teach threads, how to use threads and how to implement threads in the same course. And it is hard to imagine applications where you can use threads without having to implement them in scenarios. And so this animation stuff that we saw lended itself to that, and so that is something we should flaunt, okay? Because students who don't take operating systems will never know threads. In fact, I was at a party on Friday night and I met one of our alums, and he said, "Oh, I've never learned threads. I wish I had learned threads." And he learned it in his job. So yeah, threads. So operating system threads. Okay, and anything else?
Compiler.
And what have you learned for compilers? And scanning. That was going to be your answer too. Good, yeah. Anything else? So, you take software engineering courses also. Okay? And it's not typical. Ketan and I both try to do this, teach design patterns at all, unless you, only in software engineering courses. So the fact that you know design patterns is a big deal. Okay? And the set of design patterns you learn vary from, between our two courses. And many of you allocated diaries have mentioned the design patterns, but that's going to be a very big factor also. Okay? And I'm not sure I've covered everything. I've got slides later. Okay, if you want to be in LA, any qualities you developed here that would make you confident to become an LA?
Like helping other people out.
Helping others out? Yeah.
Just being able to use the debugger.
Debugger. Okay. That is the most important. The debugger, and so the language is being learned, but with debugger and the programming environment also. Okay. And a lot of students said, "Oh, I learned this from my LA." I didn't know that sys O will complete to sys out. I learned that from you guys who learned that from the LAs. So, it's that's what happens with the interactive. So, yes, you should feel, the topics also, that's good. But the fact that you know how to debug means you can be in LA for about any course in Java. Sometimes you just need a second pair of eyes. So even if they're doing some advanced course, the fact that you are sitting next to them and you can help use a debugger and provide an extra pair of eyes can help. You don't have to know the knowledge. So feel confident about volunteering for elections. Okay? And there are two viewpoints about teaching. One is those who can't teach, right? And the other is if you really want to learn something, teach it. And often I tell people, "Oh, I don't know this subject. I should teach it." And people laugh and say, "How can you try to teach a course when you don't know?" Well, that's the way I learn how to. And you keep learning. Every time I open my mouth here and listen to you guys, I learn something. So, take LAships. Even if you take unpaid, there are a couple of students here who've taken unpaid LAships here, and they've grown, I believe. And it's a very good experience. To go in and help out somebody. And that's what you'll be doing in the industry. Or as a teacher, either way. So internships, I told you should feel confident, and you should feel confident because of all the, the things that you know, like threads, design patterns, scanners, etc. I don't know if I told you the story, but there was one student. These are the days when all 12 assignments, no, 11 assignments were all required. 12 was always optional. There was one student who took the course kicking and screaming throughout, and then she came to me afterwards and said, "Hey, I just got a Microsoft internship." And guess what they asked me? Graphics and scanning. Thank you very much. So she was my biggest advocate afterwards. She became, one of the heads of the student organizations. So, yes, it's been work, but the fact that you know all these concepts, should help you with internships. And for the same reason, you can also do, research. And so I would willingly take anybody here who feels confident with the projects for research. Okay? You just need that information. So building an app. Lots of you guys want to build apps. In fact, we've got a new faculty member, Jeff Terrell. Contact him. If you want to build an app, he's looking for people. This is a full-fledged faculty member. I'm going to help you build apps, going to create a maker space-like thing. So do you feel particularly empowered to build an app? No? Yes? So if you build a new app, what are the things you'll have to know? What is the typical, what is something common among all apps? What are some of the things that are common? Yeah.
There has to be like some sort of screen you can see.
Some UI? You feel comfortable building a UI? I think so. Right? So there has to be a UI. Will that have to be a GUI, or can that be a command line thing also? You haven't seen many command lines. But one student said in a diary that, look, I'm going to be using buttons and I haven't used command line, but I still thought recursive descent parsing was cool. So, command line is powerful. A lot of us computer science nerds think that real programmers use command line. But, a lot of research, you might have heard of Gary Bishop's work, and it's on making things accessible. And GUIs are not great for people who can't see. So command line then offers a little bit something that can be spoken, heard. So I think that will be part of the future. Going and taking screen images and translating them into text is not going to be as powerful as command line. Okay, so maybe you will learn the command line, maybe you won't use command line, but command line is something that you would use. So let's now dissect a little bit. So I asked you guys to enumerate things you've done, and here's a list of, and again, I'm going to, I think this is cooperating. I'm really glad I upgraded my computer. So these are the topics you learned. There are a lot of topics. And we can bunch them into various categories. So algorithms. Well, did you learn any? So, a lot of this stuff was not very difficult to. The algorithm was not very difficult. Composition was the challenge. But was there any advanced algorithms that you learned or techniques you learned, Martin? Recursive descent parsing. Okay. And scanning also was not that trivial. Okay. That's why I made scanning a little easy for non-extra credit. I said there's one space between characters, but if you have multiple spaces, that was the algorithm. Otherwise, the algorithms are not that complex. Please take the algorithms class. If you really want internships and jobs, those are the kind of problems that people can test very well. So do take that class. We'll talk about that. So scanning and parsing is what I would do. Okay. Then another way to put it is that I learned advanced Java features. So you can learn Java and you can learn the advanced topics. So teaching loops, etc. They're that any programmer is supposed to do. Maybe even classes. But what would you call as advanced Java features here? If you
Generics, exceptions,
generics, exceptions,
assertions.
assertions, and threads. right? So threads, which has a lot of things in them, generics, exceptions, good. Okay? And I don't know if I have anything else here. Oh, the toolkit features too, the window system. And graphics, painting. So I have a research project on automatically detecting people's difficulty and to figure out whether we do a good job of detecting difficulty. We did some lab experiments where we had them build GUIs using Swing. And one of the things that people found most difficult was painting. So if you know, and most of these students had not taken this particular 401. So the fact that you could do painting in MVC, that's good, and it's not so easy. Just because the people did not use inheritance and graphics. So data structures, again, you're going to learn, in 410 really well. But if you had to go and say what were sort of the advanced or complex data structures you learned, what might you say? Table. Trees and DAGs. Okay, you're going to learn, and those are required everywhere. The internet is a DAG, or is a graph. Okay, so that's something you're going to learn a lot of. Okay. Composite objects. When you go and take your scene, bridge scene. Okay, consisting of avatars, consisting of arms, angles consisting of arms. I mean, that's a complex data structure you create. Okay? So that was another thing. Okay, now this is you should be able to enumerate, especially when you go to internship. So what design patterns did you learn? MVC observers. Factory. Make, factory. And what else? An undo redo pattern, yes. I talked about an app. Every app should have undo redo, right? How many apps do you know that have undo redo? That's because people don't know how to implement undo redo. Okay? So that's something that you might, so that's good. You learn that. What other design patterns did you learn? Yeah, so Bean is more like a programming pattern, like how to the conventions for a particular class, which you can think of as a pattern. So there are patterns used also for like loops. What kind of loops do you write? Okay, so a for loop is a special case of a while, right? So there can be patterns restricted to a particular class, and typically design patterns involve multiple classes. Okay, so undo has multiple classes. Factory has multiple classes. One class is design creating the methods, and other classes using it. Yeah. Adapter, delegation. Okay, so just have these on your fingertips. Okay, these are very. This is very easy, and if you can especially define them. Most people who ask you the question won't even know how to define them. So if you define them, you'll impress them. Okay, and these are not hard to define. So MVC, observer, command objects which go into undo and go into threads, factory. Okay, and if you want to refresh your, I wrote a paper on the kind of design patterns that we do here, which is linked from the course page. So you might want to quickly have a look at this paper before your interviews. Okay. So future optional courses. We don't teach a course on human-computer interaction, but if we did, then you can see that there were topics covered here, the toolkits and windows and command line that would be relevant there. Okay, operating systems. We've seen that threads would help, compiler, human-computer interaction, and we already seen. Compilers will do recursive descent parsing. So will the internet services and protocols course. Okay, what they do is they have a client send mail message to a server, So the user types in the mail message in free text, and the client has to convert that into JSON objects, which means they have to go and parse that and convert that into a form that the server can accept. Okay? So that is a course that, for those of you who have done recursive descent parsing, should be easier for you, given that you've done recursive descent parsing. Okay. On the one hand, you might say that I'll learn less from that course. On the other hand, you can say that, look, I'll do better at that course and I'll learn some of the other topics. Okay. Now, you did a project. We could have done these topics with just small assignments. You know, here's an assignment, here's another assignment, here's another assignment, all are independent. We know the pitfalls of having a project. You know, you had to get the previous things working before you got the next part. So, how would you brag about your project? You can say, oh, I'll show you my project, and you figured out why it's interesting. Nobody's going to have time to look at the project. So, what can you say about the project that can impress people who want to, hire you for an internship or a research position? Yeah.
It's really modular and has a couple different control options.
So fairly modular, and what did you say after that?
I said really modular.
Really modular.
And has a couple different control options.
And had a couple of different control options. So like the command line versus UI versus GUI.
And even like the point and click on it, I thought that was pretty cool.
That's what a student said. The student said, Henry said that to me. He said, when I got that click working, that was the most satisfying thing in the whole course. And you feel empowered, right? You can get down to the lowest level of the operating system, which is the mouse click. But I could have given you a modular project involving 2 classes. So somewhere the fact that there was a complexity involved there also should. So how might you go and enumerate that complexity? All the shape, different kinds of objects you had. So you had atomic objects, you used inheritance, you used composition, okay? Or you can just count the number of classes you had and count the interfaces too. Okay, that's also a type. And that's wow, I've asked people, okay, what is the largest program you've written before? And there will be no other class. So, do you guys have any idea how many classes and interfaces you have? 10, 20, 40, 100? Sorry? About 100, you think? I counted somewhere, so large number of classes and types, and I think it was like more like 40, 50 that I counted maybe, but maybe it's 100. But then I think, again, you can talk about various things. Like one student said, oh my God, I've got an army of listeners in my thing. So that's a nice term to use, that you have a lot of listeners, right? So I believe that this will be the largest in terms of number of classes. You write more complex code. To me, compiler is the hardest program you'll ever write if you take compilers. Okay? But you still won't have this many number of classes and types. So, this class can be sold in 2 different ways. One is, it's the first required course for computer science majors. It's certainly the first required programming course. And I always say it's the last required programming course students will take. Because the other courses are not really programming courses. They're courses on compilers and operating systems. And you have to program to understand how compilers work, but it's not a course on programming. And you will not create, I believe, in a required course as many classes. And you guys will work on a software engineering course, so those of you who become majors, you'll work with different students, and still you won't have this level of modularity. You might not even have this number of lines. You'll typically be dealing with the web. It's going to be a practical application. The tricky part will not be how to use APIs, not to necessarily compose programs together. Okay. And one student put in this thing that you had to refactor, and refactor is life. So the fact that you knew learned refactoring, that's also that's a term you should use. And if you work in industry, very few industries will let you create a program from scratch. Maybe if you join a startup, typically you'll be maintaining code and testing code and so forth. So, or refactoring code. Okay. And you know, there are certain things we don't test you in exams, but will be very valuable. So there's the programming process you followed. So you learned Eclipse, you learned the debugger, you read these long assignments, which you had to translate to code. Do you think that's going to be realistic in future? You know, in future you're going to be, you know, especially Microsoft, which I know about. There's some people who design the UI, some people who design the architecture, some people who implement. You're going to have long requirement documents that you're supposed to read. Okay? So the fact that you did that and that you were, you know, again, flaunt that if you're going to industry. Not necessarily if you're looking for a research position, but for industry, that's going to be important. Okay? And testing. So you know about Eclipse. Again, I was told that, you know, you guys learn a programming environment in 110 too, which I think learning Eclipse was a big hurdle that you overcame here. And you know Eclipse as well as you can know Eclipse, you know, in a classroom situation. How to teach Eclipse, by the way, is a research topic. So there's a guy at NC State who's been trying to figure out how to make sure that people learn the right set of programming commands. And there are many ways to do it, but you know, the fact that you were required to do certain things made you learn a few things at least, a few important things there. Okay, debugging, which is very important. Using a test suite. Now, you didn't write test suites. There's only so much we can do in a course like this. Okay? But you certainly learn about test suite, and this test suite that you learned is something called JUnit testing. Okay? So you learned how to use JUnit tests, which means that, you know, you are unit tests. You don't just say, okay, your program works or doesn't work. You know, you have little individual things that are correct or not correct. That means that's unit testing. So, but if you take software engineering courses, you will learn how to write these things too. Okay. So following requirements. And check style. So I took basic check style that I didn't write, somebody else wrote, and I enhanced that with UNC check style. Now, as it turns out, I've told you the relationship between writing modular code and plain code and security. And, you know, I wrote an NSF project which was going to deliver a piece of software, and they said, you have to prove that your software is secure. How do you prove it? One way to prove it is to go and run it through checkstyle. Literally the checkstyle tool. So checkstyle is a state-of-the-art tool to figure out your security problems. Okay? And you went beyond checkstyle. Okay? You went to my checkstyle, which is added more rules there. So that's something else that you can emphasize, and that you've gone through source code checking tools, and people want good source code. If you're going to join an industry, or even if you're going to work as a research assistant for a professor, they don't want to have code that nobody else can use afterwards. Okay? So this whole, again, I was reading one of the students' diaries, and they said, you know, code style. I really, you know, got that emphasized a lot in this class. And so that is something you really should emphasize, that look, you just didn't build big projects, modularity and stuff, big issues. Okay. So praxis and maintenance, can you see the relationship there? Reading other people's code. Okay, that is a skill. Or even if you do any open source thing, I mean, you know, I told you about checkstyle. I had to read checkstyle code. I've been reading Eclipse code because I'm trying to enhance Eclipse. And so even if, you know, what you went through, even what you learned through praxis was not very useful, you learned it all through video, the fact that you had to look at somebody's code. And that code was, you know, it had comments trying to tell you what to learn, but it didn't tell you how the code really worked. Okay, the comments were meant to tell you what to learn from the code. So you had to figure out how pieces of code worked. So again, from an industry point of view, that's an extremely important skill. Okay, they want teamwork, okay, which you didn't get here. but you also want the ability to understand code and learn code. And writing your own code is one thing, reading the code you wrote 3 weeks ago was also a skill that you learned in your projects. Okay, so you maintain your own code and you went and learned about this stuff. So that was part of the reason why I did PRAXIS. PRAXIS is a lot of work from my point of view. I could easily not done it, but that was one of the benefits I figured. Anything else you guys think you learned from PRAXIS? Version control. What does that mean?
Version control is Git and keeping your source code. Yeah, how can you manage changes to your source code?
So people want you to know to Git. Okay, now because most code is shared, and you share it in a shared repository. It's not just sitting on your computer. Now, what you did was you kept pulling my code, but at the start, some of you went and made your own changes to it, and you realized there were conflicts, and I told you how to get rid of conflicts. That you go in, and I told you a very simple way that just copy your stuff and then get a new version. Okay, just discard all your changes. But the fact that you use Git, the fact that you know how to pull from Git in an Eclipse, that's something. You take a software engineering course, you'll also learn how to create a Git repository, how to go and deposit changes there, which is not so big deal. You just take your changes and say push, just the opposite of pull. Okay, but the fact that you had experience with Git is also. And active learning is something that's because the environment was teaching you how to learn. Okay. So sharing code and version control. Version really means that you can have multiple versions of piece of code. We didn't quite see that. There was only one version that we kept track of. But supposing I have made some changes, you made some changes, and we made them independently. Now we want to merge them. So that's version control, and that's something that software engineering course will teach you. But we can't learn everything here. Okay. Now I could have picked many kinds of projects that required 40 or 100 classes, that required GUIs and command processes and so forth. And I picked a certain kind of project, and this may be too subtle, but let me try to get this point across. So, what did you build? You built this scene, right? But then the recursive descent parsing and scanning came. What did they lead to? What were they trying to do in an abstract way? They were moving the avatars, yes. But those of you who did assignment 11, what were they doing that is something more general than that? And the word interpreter above is a key here. Something that might help you with programming languages at some point, or compilers. Yeah, sure. So that was recursive descent parsing, syntax-free parsing. But the commands, was there something interesting about the commands that went beyond the application? The commands going, sorry? Calling each other. That's good. Something more programming. Were the commands letting you program? Did you have a loop? You guys wrote loops there, right? You learned how to, you interpreted a student's loop. A loop, you would say, repeat so many times. Okay? You defined operations, then you use them. That's what happens in a programming language. Okay? So these commands were really doing a little programming exercise. Okay? You had the basic operations, move this, do that. That's fine. That's like the atomic operations. That was nothing general there. But how you compose them was to make them write them in a loop, define a little procedure, and then go and call the procedure later. Okay, which is all very programming languages, very general. I bring this up because how many of you learned about or know about the Alice environment? Okay, 2 of you know. Can you describe in your words how Alice works?
I haven't used it in a long time, but it's basically a world, I think, where you have like a drag and drop environment where you can move stuff around.
And how does it teach programming?
I didn't really teach it programming.
I haven't used it. I'm just familiar with it, but it just teaches logic.
So that's right, it's a world where you can move around objects. And how do you learn programming? You go and interactively write loops, and write if statements, and write methods. So a lot of beginning programming is taught using Alice. What you've done is essentially create an Alice. You created a world of this bit scene, and conceivably somebody could learn programming by using your loops and your methods. Now it's not that fancy as Alice, but it's in that direction. So the way to say that is that, hey, I could do an Alice-like environment. Okay, when you do compilers and interpreters, that we would more so. So there was some programming involved, some implementation of programming involved there too. Okay. And building an app, if you want to build an app, you need a user interface. You need to figure out how to handle errors. Okay. I think the web apps don't require threads, but how many of you built a mobile computer app? Has anybody done that? Are there threads? Threads in there are threads, yeah. So you'd probably create threads then. In fact, yeah, I remember now seeing stuff. And there's probably multiple user interfaces possible there too. Scanning, parsing, maybe not so, but maybe in the future. Some kind of geometry processing and use of window systems and tokens. Okay, that's important. So you should feel empowered to do so. Okay, and you learned object editor, and object editor you learn how to visualize data structures in a logical way. Okay, so visualization of data structures within the debugger object editor. So again, the diaries were meant to make you guys less, more articulate, and I don't, I'm not sure how well they work, but I have talked to a few students who said that yes, they're really good for. Those of you who did the diaries, I think, felt it was worthwhile. Those of you who didn't, either did it through compulsion or didn't want to do it through compulsion. But you learn to abstract and quizzes and exams. So there's many ways of teaching programming, and one way of teaching programming. And some people have asked me to do that in class, which you can't do in 401, is you say, okay, watch me program and you learn something. Okay? I can't tell you what you're learning, you can't tell what you're learning, but you learn something. Okay? And it's not a bad idea. I mean, that's like saying, watch me play tennis and you'll learn tennis. Okay? A lot of tennis you do learn by watching something. But, to go and then say, look, here are some pros and cons. You can hit the drop shot here. You can hit a lob here. You can serve to the wide here. That's kind of making things articulate. Okay, so with quizzes, it forced me to figure out, what are you guys really learning from all this? So the PRAXIS are a way of saying, okay, don't watch me program, just program yourself. Okay, but then the quizzes make sure that you could articulate what you learned from that. Okay? So that was the goal. Okay, so the fact that you went and answered God knows how many questions in the quizzes means that you learned so many different things that you can articulate in a non-programming way. Okay, in a conceptual way. And again, I saw some diaries saying that I did the assignments, I did the quizzes in PRAXIS, and I really was made to think. And then the lecture sort of brought it together. Okay, and I think this is the last thing. So I'm going to argue you learn 3 kinds of modularity. Can you try to figure out what the 3 kinds might be or what multiple kinds might be? You can just say we learn modularity, or you can say there are really 3 kinds of modularity. Or multiple kinds of modularity.
Delegation.
So that's like a pattern. You can learn different kinds of patterns. Yeah, so yeah, I'm looking for a certain answer, and I can see yours being a perfectly valid answer to this. But design patterns is one kind of modularity. Okay. And that modularity involves, let me give you a hint where I'm going. That kind of modularity involves breaking the program into multiple classes. Okay? So breaking the program into multiple classes is one kind of modularity. What else did you learn?
Inheritance and the use of interfaces.
So that's also breaking a program into multiple types, right? But yeah, using inheritance, using design patterns, or using these types. Okay, good. So you can break up a program into multiple classes using design patterns, or using inheritance. Okay. So how to break things into packages? Good. Monty? Breaking a class into multiple functions. And where did you learn that? And which project was that most evident in? Parser. Okay, that was the one that was more evident. That is something I really believe 110 should be covering, so I didn't really cover that much. But the parser was sort of going on steroids in terms of how to do it. Okay, and then what can be a third class of decomposition? So breaking a process into multiple threads. Okay, so these are the three kinds that you've learned, and class decomposition into methods, program decomposition into classes, and process decomposition into threads. Okay, so that's another way of looking. We've learned a bunch of things. I'm just giving you different points of views. Okay. So what did you not learn? You didn't learn everything. You didn't learn distributed systems. You don't know how to have two programs. There are two different processes running on different computers, how they should talk to each other. Okay. That's the course I'm teaching next semester. You didn't learn efficient and complex data structure, how to even think about them. That's what you learn in algorithms and data structures. Okay. You didn't learn how a computer system works. You learned a little bit about scanning works, but you didn't really learn compilers and how operating systems work and what the underlying architecture is. And this is all fun stuff. Okay. For those of you who are deciding between different majors, this is what makes me excited about computer science. Okay. And we talked about the halting problem. We didn't prove the halting problem. You can, in fact, in an undergraduate class, prove the halting problem and many other problems. You can prove that certain algorithms cannot be done more efficiently than this. Okay? That don't even try to make it more efficient than this. Okay? What problems are exponential, what are not exponential, what can be done, which means exponential means, it just takes a long time. The linear algorithms are the most fast. You can prove that certain algorithms are not linear. Okay? You learn models of competition, like the next class that comes here, they learn about Turing machines. You might have heard of Alan Turing, from the movie at least. And, he did a lot of these to prove. He had a Turing machine, and from Turing machine, which is like, Turing machine is even more powerful than your computer. You can prove that, you just can't do things more efficiently than this. And that's very important to know, because, security being a big deal, you can prove that you can't prove that a program is insecure. If you can't tell if a program will halt, you can't tell if it's insecure, whatever that might mean. You can't prove that two programs are equivalent. So I can't go and write a theorem that goes and takes your two programs and say, are they both equivalent? I can't do it. Okay? So you know what not to do, or what you can do approximately, perhaps. So that's what the future can give you if you continue. Okay, I think this is my last slide. And you didn't learn team programming. Okay, and that's something you learn in software engineering course. Okay. Through PRAXIS, I encourage you guys to talk to each other. Some of you did, but I found that most people want to do it themselves. That's why I never worry about plagiarism in this class. People just get involved in their own projects, and that's their thing. But the fact that you talk to each other during PRAXIS, I think, is a good thing. But if you did it without talking, that's also good.